All right. Hope everybody had a good weekend. We are back with our first full week of the second semester, I should say. The only big item that we have coming up is next week is going to be your first exam of the 6 weeks. Look for it to cover inverse trig functions, what we've been talking about. In fact, I'm still working on it, but I've got 11 questions, 10 of it's multiple choice, and the last one is going to be where you measure using your protractor, just like we've done last week, what we did on the quiz, all that good stuff. The other part is going to be what we're going to start tomorrow, those trig identities. All 20 of those. We're going to start looking at those and seeing how we can use them to simplify expressions. So we're going to be spending some time on that for a while. Other than that, this weekend, you got a 3-day weekend. We don't come to school on Monday. We're just going to keep going as far as we can. Got our first focus activity. Everybody have a good weekend? Yeah? It was good, except for Saturday night. Kind of disappointed. Boys. Yeah. Again, looked horrible. But, overall, I got to say it was a pretty decent season. We started out rough. We ended rough, but I don't know. Yeah, we'll see. Okay. But number one, focus activity. A cruise ship sailed due west 24 miles before turning south. Okay, so went west and then south. When the cruise ship became disabled and the crew radioed for help, the rescue boat found that the fastest route covered a distance of 48 miles, so straight from the port all the way to the ship. Find the angle theta at which the rescue boat should travel to aid the cruise ship. Okay, so the diagram is already set up for me. We got a right triangle, leg of 24 miles, hypotenuse of 48, and we're looking for this theta right here. So why don't we go ahead and list the sides in terms of x, y, and r. Okay, r is definitely this 48, and I apologize for the blurriness of that. It wasn't the best photo that I took, but we get the idea. What does the 24 represent? That's the x, that's the horizontal, okay, the adjacent. So the other one would be the y. So it looks like the two sides we have are x and r, the adjacent and the hypotenuse. So what trig function can help me here? What trig function is going to use x and r? We can use what? Cosine to work out, okay. We know that cosine of theta is equal to x over r. Or we could use its reciprocal. What's the reciprocal of cosine? We could use secant, which is r over x. So which one would you like me to use? Cosine or secant? Or does it really matter? No. As long as you choose a trig function that will work with what you have, you should be able to get the answer correctly. Like in this case, cosine of theta is going to equal the adjacent x over the hypotenuse r. So 24 over 48. Okay. What is 24 48 if I were to reduce it? Oh, not 2. If we were taking the secant, yes. So it's 1 over 2. So that would reduce to 1/2. And even if I didn't do so, I'm still going to be able to get what I need. Now, let's go ahead and take a look. Cosine theta of 1/2. What we want is to find theta. So cosine inverse of 1/2 is equal to theta, right? Remember, you evaluate a trig function at an angle and you get a ratio. So theta represents, some angle. And we have a ratio here. When we're evaluating an inverse trig function, we plug in a ratio and our answer is going to be an angle measure. Okay. Well, what quadrant would this be in if I were going to go ahead and draw a triangle? Number 1, remember cosine is restricted to 1 and 2. So why do we say 1? Yeah, because it's positive. Okay. So let me go ahead and diagram this real quick here. Give myself a little more room. Okay. So in quadrant 1, I'm going to go ahead and draw my terminal side. Okay. So here's the theta that I'm looking for, right? I'm always going to connect it to the x-axis. There's my triangle. Now, we know that we're just taking a inverted form of the triangle we have there, but we know that the adjacent is the 1, the radius is the 2. See, that's my x over r. Okay. So how can I find this height y? Pythagorean theorem. Okay. What is the Pythagorean theorem just general? A squared plus b squared equals c squared. So using the side lengths I have here, I would say 1 squared plus y squared is equal to 2 squared. Well, 1 squared is 1 plus y squared equals 4. 2 times 2 minus 1. Okay, solve the equation. Those cancel. Y squared should equal 3. And how do I get y from y squared? Square root. There we go. Okay, so this is actually the square root of 3. We know it's positive because we're in the first quadrant. Is this a special right triangle? Yes. Which one is it? Okay, now how do we know immediately it's not 45, 45? The two legs that form the right angle would have to be the same. Okay, so this one is a 30-60. We'll notice the hypotenuse is exactly double the shorter leg. And we know if I take the shorter leg and multiply it by square root of 3, 1 times square root of 3 is square root of 3. The only question, this angle right here that I'm needing, is that the 30 or 60? That's the 60. So that one has to be 30. So theta here should be 60 degrees. Or what would that be as a radian measure? Pi over what? Pi over 3. Yes. Okay. Questions? Now remember, you'll still have the calculator, but I think it's really helping you to make a connection if you look at it in this way. You know, think about the triangle and what it's telling me. In fact, we could just go on over here to calculate, if it'll let me. Let's see if it'll do that thing again. There it goes. So we're looking for cosine inverse. And I'll just escape out of that. There we go. It ended up being 1 divided by 2. Okay. And there we go. There's the 60 degrees that we got. Okay. So if we're thinking in terms of the diagram, okay, because we're eventually going to get into vectors. If we have north, south, east, and west, okay, well, I would say we should probably go west of south 60 degrees. And there are particular ways that we say that so you know exactly what direction you're going to go ahead and go. Okay, because think about them in the quadrants, and we'll talk more about that later. Okay, did anybody have that good to go before we started? Okay, does that make sense? Okay, good. We'll put that to the side. Probably in a couple of weeks, I'll go ahead and tell you we'll be turning these in, and hopefully it should be just an easy grade for you. In fact, I'm going to take the extras I have here, and I'm just going to place them in Monday's folder in case you do happen to misplace or lose one. Okay. So let's see. We are going to wrap up inverses today. And looks like we got through example 3 on Friday. So we only have a couple of examples left, and then we are done. And as I said, tomorrow I'm going to go ahead and start with the trig identities. In fact, on Friday, did I go ahead and pass out the sheet that had all those identities on it? Okay. So I wanted you to go ahead and have that. I'll see if I can have extra copies of that by tomorrow. But here we go. Find the value of cotangent inverse of 1/2. So this lesson that we started on Friday, we're looking at taking the inverses of the other 3 trig functions. Up till now, we've always been focusing on sine inverse, cosine inverse, and tangent inverse, right? Well, how do we evaluate these? What did we start doing the other day? Started with an R. We took the reciprocal. That's exactly right. If we had an expression that was secant inverse, we just took the reciprocal trig function and then the reciprocal of that ratio. So that's why here we have secant inverse of 2. Well, that's the same as cosine inverse of 1/2. I took the reciprocal of both. What's the reciprocal of cosecant? Sine. Okay. So we change cosecant inverse to sine inverse, and then x, the reciprocal, becomes 1 over x. There was one additional new notation we had the other day. It was just a different way of writing an inverse. What's that 3-letter word? Arc. So if I were to have something like, tangent inverse of x, this is exactly the same if I were to say arc tangent of x. Okay. Instead of using the -1 notation, we just put that little word in front. Tells me we're dealing with an inverse. Okay. Now the only one that we have to be careful of is going to be cotangent inverse, and there are reasons why we do it this way, but I'm not going to worry about getting into them. All we need to know is the ratio. If it's positive, greater than 0, we're going to use this formula. If it's less than 0, meaning if it's negative, we have that same formula, but then we're going to add pi. And then if it's equal to 0, the answer is just pi over 2. Okay. And remember, what are you always able to do on your tests and quizzes and such? You can always use your notes. Okay. So you don't have to commit these to memory. You'll be able to use those. All right. Well, the problem that we are currently working on is a cotangent inverse. So here's my question. Cotangent inverse of 1/2. Is the 1/2 positive or negative? It's positive. So if I'm looking back over here at my list, because it's positive, I want this top one right here. So all I have to do is take tangent inverse of the reciprocal. Okay, so let's see. I'm going to come on back over here. So tangent inverse of 2 over 1. Now the reciprocal is just 2, but I'm going to go ahead and leave it as a fraction because we're going to use that to create a triangle. Okay. See, once you take the reciprocal, it's in terms of what we've been doing all last week. We are good to go. All right. Well, let's see here. What quadrant would this be in? Well, the first. It's positive. There we go. Okay, so let me move this out of the way here. Let me try that one more time. There we go. Aha. So I've got a coordinate plane here. This is where I'm going to go ahead and just kind of draw the rough sketch, and then I'll use this bigger quadrant down here to go ahead and draw it with the protractor. Okay. So we're in quadrant 1. Okay. Here we go. So I want to go ahead, find this angle right here. Okay. That's going to give me my answer. So what is tangent's ratio? Remember, it's always y over x, opposite over adjacent, right? So y over x. So these are my side lengths. So the opposite y should be 2. The adjacent x should be 1. Okay. Now I want to go ahead and find the third side, the hypotenuse, and I'll use what again? Pythagorean theorem. Okay. So let's see here. That would be 1 squared. Let's say this is r, plus 2 squared is equal to r squared. So 1 squared is 1, 2 squared is 4, so that would give me 5 is equal to r squared. So what's r? Square root of 5. Now, why on this one am I going to be forced to use a protractor? It's not a special right triangle. It has to be either a 45-45 or a 30-60-90. Okay, there we go. Now, they're all always going to be 90, but it's not 45-45 and not 30-60. Okay. Now, this one, we're not going to have to worry about converting my measurements. See, these legs, this one's actually really nice to me. We got some nice whole number values. So I would just go ahead and say, do these in centimeters. If you ever did end up with a radical, like on the hypotenuse here, square root of 5, well, how are we able to get a better measurement? We took the centimeters and we converted it to, not meters, millimeters. There we go. Millimeters. So we just multiplied it by 10. All right. So let's see here. So I've already got my quadrant 1. So I need to reproduce this triangle just with the accurate measurements. So first off, I need 1 centimeter. So let's see here. Again, I'm going to go ahead and put where the measurement begins, not where the ruler begins. Okay, so let's say 1 centimeter is like right here. Okay, would everybody agree? All right. And remember, if you feel there's enough room, if you want to do this in inches rather than centimeters, makes no difference. Okay. It will if you need to convert it. Okay. All right. Now let me go ahead and get the vertical. So from here, I need to go up 2. So let's say 2 is right there. Whoop, that's a little low. There we go. So there's my 2. So I went 1 centimeter right, 2 centimeters up. Okay, let me go ahead and get this ruler out of here. And starting at the origin, I'm going to go ahead and put a line right through that point. And if you want to go ahead and finish up the sides of the triangle, you can. I went 1 centimeter, 2 centimeters. Is everybody okay with how I measured? Okay. Now I'm going to put my protractor right on top, and I just want to know how far we rotated in order to get to that line. Okay, so I think my protractor is just up here. And it's still on it, so there we go. Hey, it's still doing it, so I'll try one more time. There we go. Now, how do I go ahead and measure this? How do I line it up? There you go. I always put the crosshairs of the protractor, this guy right here, right on the origin, just one right on top of the other. On your protractors, you just have that little open circle there, so that's what you'll put on your origin, or if you have your own protractor. Okay, so let's see. I'm going to line this up. I'm going to put one right on top of the other. Okay. So I'm using the inside track. What do you think? It's definitely between 60 and 70. You'd say 64? Okay. So if we were to choose, and this is what you'll be doing on like your test, choose the whole number value. Like what number? Bless you. You good? I was just thinking because now everybody's looking at you. At you? Okay. So what would you say, 63 or 64? What would you want to put? 64? Okay. So let's say this comes out to be 64 degrees. Now remember on the test, okay, and I'm thinking about doing another like little exit ticket to give you a little more practice with this coming up on Thursday, because tomorrow I want to spend time actually getting to know the identities. How am I grading this? What did I say I would do? Just in case your measurement's a little off. Yeah, I'd go 5 up and 5 below. So the highest we could go would be 69. The lowest we would go here would be 59. So anywhere from 59 to 69, I think that should cover any measurement errors you might have. But let's see how close we got. We want to go ahead and say it was tangent inverse of, what was it, 2? So I'll just say 2. Oh, if it'll take it for me. There we go. So tangent inverse of 2, we said it was 64. So 63.4. Okay. You said 63.5? Very good. Okay. So there you go, measuring by hand. Is everybody okay with that? Yeah. Is anybody having trouble? No? Okay. And our last ones. Now these here, does anybody remember what we call these? Blank of functions. It starts with a C. It's been a while since we've seen them. Composites, yes, that's exactly right. Okay, so we call those compositions. Oh, dang. It's right there, composite functions. Now, you might remember, I was like, yes, way to go, Brandon. Oh, it's right there. Okay, but still, way to go. Okay, but this is how we normally saw them way back in the first semester, f of g of x. Do you remember those? Where we'd have to evaluate the inside function. That answer would be the input for the outside function. Okay, and then we'd go from there, and we looked at that through a variety of methods. So what we're doing here is the exact same thing. Okay, we want to go ahead and evaluate this. Cosecant inverse of cotangent inverse of 1/2. Okay, now do you notice anything? Where would I start? With the cosecant or the cotangent inverse? Cotangent inverse. Remember, we always start with the innermost function, right? But that's what I'm talking about. Do you notice anything about that? Okay. Yeah, isn't that the one that we just saw? Okay, so we already know the answer, right? But I want to go ahead and show you that in order to evaluate a function like this, you don't necessarily need to know what the answer is going to be for the inside. And let me show you what I mean. Choose one of the 6 trig functions. This is kind of a little cotangent, okay? So let's say cotangent. If I have cotangent, I'm always going to evaluate him at an angle, right? Okay. And what kind of answer am I going to get? I'm always going to get a ratio, the sides of a right triangle. Well, now what if I work backwards? If I evaluate cotangent inverse, what am I going to plug in? I'm going to plug in a ratio, and then my final answer is going to be an angle, right? Okay. So if you're thinking about this big picture, the answer to an inverse trig function is always an angle measure, right? So that's what my inside function is. Cotangent inverse is going to give me an angle measure, but then what's going to happen when I go ahead and evaluate cosecant at an angle? Shouldn't I be getting a ratio as a final answer? Okay, same idea down here. Okay, secant of cosecant inverse of -2. Okay, cosecant inverse An inverse trig function will always give me an angle measure, right? So if I evaluate that and get an angle, and then I go ahead and plug in secant of that angle, well, what should my final answer be? Go away, Cortana. There we go. It should be another ratio. So if we keep that in mind, okay, you don't actually have to solve that angle measure. So let's see here. Cotangent inverse. So forget about the cosecant right now. Just put him out of your mind. Okay. We already knew that he was in quadrant 1 because the 1/2 was positive. Remember, if I were to evaluate this, we change it to tangent inverse of 2/1, which we just did. And we ended up with this, right? Okay. All right. So we said the opposite was 2. This was 1. We ultimately got square root of 5. And then we were looking for theta, right? Which we said was about 64 degrees. I think the approximate was 63.4, if I were to look back at that. But see, here's the thing. I don't need to know what that exact angle is. Do you see how just by the inverse I was able to create the fraction? Okay. And remember, cotangent inverse is just going to give me an angle, but it represents this angle right here. Now, whether I know him or not, cosecant just wants the ratio from that angle's point of view. Remember, what is cosecant's ratio? Oh, now be careful. There we go. R over Y. There we go. Because think about it, if you ever get confused with that, what's the reciprocal of cosecant? It's sine, right? And we know that's Y over R. So cosecant has to be R over Y. So see, the fact that we know that angle really doesn't matter to us. We don't actually need to know it. So what is, using this triangle from this angle's perspective, what's the R over Y? There you go. So it has to be the square root of 5 over 2. Remember, we said our answer, our final one, has to be a ratio. Okay. Is everybody okay with that? Okay. Let's try another one. Find the exact value of secant of cosecant inverse of -2. Okay. So now, forget about the secant. Yeah, for just the secant, forget about the secant. Yeah, you'll have later. So the reciprocal of cosecant is sine. So I'm going to say sine inverse of what? Okay. So a -1/2, right? Okay. Well, what quadrant would I be in here? 1 or 4? Why 4? Okay, because it's negative. Okay. So you'll notice it's already set up for me here in quadrant 4. So I'm going to go ahead and draw a triangle. Okay, in quadrant 4. Connect it to the x-axis, just like I always do. So here's the theta that I would normally be looking for. Okay. Now, the opposite would be 1. The hypotenuse would be 2. Which one would have the negative? 1. That radius is never, never, never negative. It's always positive. Okay. Now, here's the thing. How am I going to find that x distance? Pythagorean theorem. Okay. So what's the equation using x, -1, and 2? So -1 squared plus x squared equals 2 squared. So -1 squared is 1 plus x squared is equal to 4. Now what? Subtract the 1. So x squared is equal to 3. So x would have to be the square root of 3. Okay. Now here's the thing. Is it a perfect or a special right triangle? Yes. It actually turns out we know what that angle theta is now. But this is the point that I'm trying to make. If we realize that the answer to an inverse trig function is an angle, and if I go ahead and plug that angle into a normal trig function, I'm just going to get a ratio. Okay? So from this angle's point of view, whatever it turns out to be, what's secant? Okay. So would you agree Brandon says r over x? That is the reciprocal of cosine. So he says that would be r2 over square root of 3. What do you guys think? Okay. Now we want to rationalize. Thank you so much. So what does that mean, rationalize? There you go. So what would my final answer be? 2 square root of 3 over 3. Okay. Now let's check it. Okay. Let's see if this is actually correct. Okay. If I come on over here, we had secant of cosecant inverse. All right. So control divide. We had 2 square root of 3 over 3. So there's the, whoop, sorry. Put that in the wrong spot. So there is the decimal value of what we just found. Now let's go to trig. We had, it was secant of cosecant inverse, right? And it was -2. Okay, there we go. There we go. Matches up perfectly. Okay, just like that. Now let's say if we go back over here, okay, I mean if you want to go through the whole way, what angle would that be? Would that be 30 or would that be 60? Okay, why 30? Okay. And also be careful, we're in quadrant 4, so it would be a, excuse me, -30. Okay, because we'd have to rotate clockwise, right? So cosecant inverse of -2, you're telling me the answer is -30? So if I take secant of -30, should it still give me the same answer? Yeah. Okay, so let's see here. Let's go to trig, secant. Come on, there we go. What was it, -30? And I'm still in degrees, so this should, well, okay. But that's just what I'm trying to show you. If you still want to go ahead and find the angle and then actually go ahead and plug it in, that's perfectly fine. But you don't have to worry about that if you notice that the cosecant inverse is an angle, and secant of an angle has to give me a ratio, and I'll already have the triangle here. Does that make sense? Okay. Any questions? How we doing? Doing good? Okay. Well, that is actually all I have for today. Tomorrow we'll go ahead and begin the identities that I passed out, and I'm thinking on Thursday we'll probably have some kind of exit ticket. Take about 15 minutes or so, have you do a couple of these, measuring again just for some more practice. Okay. All right, good. Save changes, sure, why not?